Okay, welcome back to the practical lecture 0.1 of the HPC course. A short introduction, a really short introduction to UNIX and SSH. So in the previous part, in the part 1 of our lecture today, we really had a very brief introduction of UNIX. So we looked a little bit into what the folder hierarchy is. We looked how we can create folders, directories, really, and how we can navigate through them using the cd command, change directory. You remember going up to the hierarchy, we had cd point. We had basically then the VI editor as an example, although again, as a frequently asked questions from students, basically you really can take an editor as you want. I don't really want to say that everybody has to use VI. And you can use Nano, for instance, that many people have used before, or even Emacs. And I think people have come up with others as well. So it's really not that I wanted to show you this is the editor you have to use. It's much more thinking about Unix files, because many people much more in these days have an app way of thinking. But even usually apps need some files to store data. And we have seen when we're writing our message, hello to the course, this is data, we have to store it in a file. The file is in the directory to be found. And this is an important part that we'll be coming back to in the whole HPC lecture series. Every time we have a job script to submit a job really to this HPC system to really work on something, which is called this job thing. So meaning it could be an execution of a simulation, could be execution of a deep learning training. All of these things, of course, don't really mean anything to you yet, but we'll come and see how that materializes when we are at the different lectures. So in the second part, really, we want to have a little bit more look on this SSH. If you remember, I was magically using a sort of Mobix client, which is essentially an SSH client. And I just pressed on one button and I was logged in. A short passphrase, okay. So of course, I want to bring you a little bit now the idea of this SSH a bit more basically to your heart, because you're using that again and again in the course to use a deep test cluster or to use our UTIN system here in Iceland. And so it's very worth to doing it because, as we learned in the first part also, SSH is quite common and is perhaps the really access mechanism how you can access many different systems. Some of them are moving these days to more being used with scientific gateways, with browser-based solutions. The data science community has now Jupyter notebooks using mostly Jupyter, basically with data sciences then on HPC systems without necessarily going through SSH connections, or scientific gateways like the Ultrascan scientific gateway, where we also were once involved a little bit. So this means you just use a kind of browser system as well. However, if you're more technical and really basically use systems with a scheduler in a very direct point of view, I would say still that the majority of the systems are still accessed by SSH. And then, of course, if you're an administrator, then for sure, because we are here in the computer science department, also think about that many of you maybe also then become maybe administrators of systems. And for this, SSH is really an important part of a HPC system to know. However, when we talk about this, we will not go on the direct SSH level. We don't look at the packages which really go over the wire. I just give you roughly a couple of tools and the basic understanding here. It's a short introduction. Of course, of SSH, you can do different ways of teaching it, but here this is really optimized for getting up to speed with our assignments, which will be handed out very early in the course so that we have enough time in the end of the course for preparing for our assignment. That's why we start already very early on with practical, really, ideas of how we can basically solve the assignments. And as you can imagine, this SSH keys and the SSH access to the systems will be always one of the first part of the assignment, because when you cannot log into a system, then you cannot do anything on the system. You have to be there, you have to be on the system. So how you do it? There are different ways of doing it. I will demonstrate here now one which is very general here on the top right with this graphic. The idea of this, let's say, SSH key pairs that you usually have is that you basically have a certain, let's say, private key and a public key that you created, and you can put different tools for it. In Unix, there's SSH Keygen, for instance, but also you can use Mobixterm to create it. There's even PuTTY, another SSH client that you see here for the client, basically for the clients on Windows, for instance, that you can use there, and to create a private public key pair. So the public key you usually have to upload or let them known, and you can do this because this is not a secret. The public key you can use and load it up, as we will see also during one of our assignments. You will upload one of the keys in order to get access to the deep test cluster. Now, this is a kind of step firsthand. So you create the keys, afterwards you upload the public key. However, remember that the private key here is a private key store, for instance. It will always remain essentially on your computer. You should never upload that somewhere, not even to a HPC system. That should be always on your laptop or on this interesting desktop PC here. So how it works then usually is that when you initiate a connection, and we will see this now with what details you're going to use for that, then you basically contact the HPC system that you see here, and you will use your private key to connect. Because you have uploaded previously your public key, the HPC system knows that, okay, here is someone connecting, a user, and I simplify a bit here. There's also a handshake, etc. But you basically have the public key that is actually matching the private key that nobody knows except you, the one that was creating this private public key pair. As these both keys fit, there will be basically then an instance of the connection, basically that you have then an SSH connection has been established. So this is a very theoretical way of putting it. I understand that. So we will come back to some demonstrations, of course. Now, but if you think about the SSH, it is a protocol, so you know exactly what's happening through the wire, and you can look this up. But essentially, it is providing a really secure channel. And this is where we're interested in, because we want to have not everyone accessing us actually our systems. And we want to exactly know who is connecting to this, basically. And it follows, as you see, a client server architecture, really. So it's basically an SSH server hidden here, where you have a client essentially then accessing it. And with this right private public key pair, you actually can go in. Now, this is, let's say, the way of using it with keys. But I also want to show you that, of course, in a way, the SSH is a protocol. So you can also use it in a less secure manner by just using username and password. So the deep test clusters that we use in Jülich are basically using keys like any other production system there. But our U-turn system is a teaching system. So it's really not a production system in a sense that like big scientists are using it for daily jobs in earth sciences and environmental sciences or so. That means a teaching cluster, it's okay maybe to just have a username password access for that, and don't really use these keys that I just was alluding to. Hence, I will demonstrate you both ways a little bit. So what you still need, however, is an SSH client. And here, the good news is that Unix always provides an SSH client, usually inherently, and also usually the Mac environments. So the only people that have a little bit, let's say, a small ramp up period in the assignment will be the Windows people. You see, I'm also one of them, but I basically have here different tools I can use. There's one system called PuTTY that some of you maybe know. But interestingly enough, it's always the first tool that the people install when they are there. And just to really take this lessons learned now into basically the lessons learned here in the course, my recommendation is really don't use it. It has lots of drawbacks. It is a very simple client. It works almost everywhere, but don't really use it. Better install the Mobixterm. I will come to this in a moment. However, it shows you nicely here just what, if you want to use PuTTY for whatever reason you like it, that's okay with me. Then you just use it. I used it a long time as well. You see here in very old times, accessing different parts from in future grid and MapReduce, things we do in the cloud course. So, but still, the key essence now for getting access to these systems would be several different aspects. And the first aspect is really the host name. The host name is here an example Hekla in Iceland at rhi.hi.s, which essentially would be then one HPC system. No, it's not, because we have here workaround. I will come to this in a moment, but usually this IP address will be then a HPC system you put in, and usually SSH operates on the port 22. So these are things you have to know in order to use SSH. You cannot just use SSH blindly. Usually you need a host name you want to connect to. The other end of the equation is a username. So in order to use SSH, you basically want to connect with a specific user to the system, which means you have certain usernames which you also should know. And this is something usually you get when you get accounts on these systems. And we will have in our first assignment already this part where you get accounts to the system. With the UTune, you already have automatically an account we will talk about, and we will basically create for you based on your UGLA identity. But essentially, you will have a username by some form of registration mechanism, and this is everywhere in the world on HPC systems. You first basically have to register or basically get an account on these systems. So with these, basically, you are ready for SSH already. So the only thing is, of course, now the question of how you really prove that it's you connecting. Hence, there are now these two ways I was alluding to. Either you got the username and the account with a password, and hence for you in Iceland, this might be then for UTune, usually the password coming from UGLA and your UGLA identity as username. But in the deepest that we see in the test cluster, you will get something basically on your last name with some form of a number when we upload SSH keys. So there you don't really get a password. Instead, you have to create SSH keys before to upload them. However, both of them are based on the same information, essentially to connect. And this would be really, again, the username and the, let's say, host name. So this was PuTTY. It's the same way you can use now Mobixterm, where you put all the information in as well in order to connect to these systems. And I will demonstrate it, of course, so that you get a much better understanding what I just here theoretically introduced. So also Mobixterm does nothing else than basically uses the private key, and then the machine will check with the corresponding public key. And then once this is matching, then you basically get an SSH access. And of course, you can also use it if you want to connect, as we will see in a moment, also when you just have, let's say, a password. This is how an example of a, let's say, public key looks like. You can imagine why I'm not showing the private key, because this is, of course, my secret and should be also your secret. So don't share that in a chat or any time. The private key remains yours, should be never basically leaving or actually exploited. Of course, you have to show it in a way to this SSH client in basically to show and prove that you have a matching public key. That's the only way how you basically will use it. And this will be, of course, parts of our assignment, how we will generate those, how we will use these keys. So again, it's a very, let's say, interesting practical lecture, but maybe some really new aspects for you. But we will come, of course, throughout the course of these lectures with assignments and also with theoretical lectures, again, of using these protocol and keys again and again. So it will be, at the end of the course, something you will really use and know naturally. So when we want to use this now and make a little bit of demo, I created some slides. Of course, we want to also see something in practice. We start a little bit with having now this deep HPC system accessed. So again, here I'm in this Mobixterm that I will really recommend. You see here a frequently asked question from students that I have the professional version, but you can also use a free version that is actually online. That's not a difference for this course. And when we now, you remember in the first part of this lecture, I just pressed here, but of course you can imagine these aspects that I have here, which are essentially all the sessions we have. And the latest one was this one that I just pressed. And if we edit this session, you can directly see similar things I would put in PuTTY from the last slide. So here I have a remote host. This is really the host name I want to connect to, the deep.fz-jülich.de. This is something which will never change. This is for everyone the same. It's a host name of the system, of the HPC systems we want to work with. Now what's going to change is your specific username. You see, that's kind of bound to my name, so you will also receive from the system, which is very unique. So only you have this identity of the system. And of course, as I said, this is not enough. So I can always pretend I'm Riedel1. So you can pretend of Riedel1. You can try if you want, but you will see the SSH connection will fail. And this is because you need this private key. And here's an option to really specify this. You see, use private key. And here we have the one that I already prepared, which is part of your assignment to really prepare one. So don't worry about this, how to create them. And then I can, just use this one here that I have as my private key. As you remember, it should be not shown. That's why I stop here and don't show you much more on this. Just take away the message that these 3 key considerations. So you really have to go to advanced SSH settings and really specify the private key. It's again a frequently asked questions from my assignments. Usually people sometimes forget the private key. However, we more and more write it in the assignments again and again that, of course, though, remember, after you generated the public and private key, the public one is uploaded, but the private key needs still to be used here in this SSH client. But the assignments will be a little bit like a walkthrough here and there with some programming assignments every now and then, but very, let's say, smaller programming assignments. The idea is really to understand power computing, not to do software engineering or software development. That's what Matthias Bog teaches very well in other courses. That's not what we do here. We rather want to understand what's parallel programming, what's the difference to this. However, coming back to SSH here, and it's now important that we specified all of these 3 elements, and now we want to connect and see what's happening. So this is essentially this, or when I want to demonstrate it maybe completely from scratch, we could say that we have this deep.fz-jülich.de. We say we have a specific username called Riedel1. And I want to demonstrate it now without specifying the private key so that you see what's happening. You see session stopped, nothing is happening because we didn't present it the authentication key that we require. You see no support authentication methods available, right? So we need some way of saying how we basically want to connect to it and how we want to prove that we really Riedel1. So when I create my next session, I should of course know that. And by doing so, we can do the deep.fz-jülich.de, specify my user name. And then that's now really important, use a private key. And as I told you, there are already some of them which are really prepared here that we can use for this and can really go and now have this included. That basically should work. A small requirement perhaps, but you see there's no problem of using this. And we want to check if you're really there. I mean, we get a welcome screen now here on deep on the test cluster, but you can also see that when we use again this kind of things, let me increase this. If we use the UNIX command, for instance, we just used here, basically this is now really this interesting deep test cluster. Now, this was a way how you do it essentially, and of course, when you think about who am I, maybe just for the curiosity, this is of course now matching to this kind of SSH session that we have generated here. You see again that this deep.fz-jülich.de is an alias for a real machine name that is basically this one. Right, by having done so, let's come back shortly to the slides. You see essentially the same information here. Of course, note that you have to first create such a key and then upload this key. But this will be part of the assignment really to do and then to understand this a little bit more. And when you're there, you have seen basically this welcome screen. It's a very important screen when you come to this welcome screen in the SSH domain, usually you see lots of information about the system. And this is quite informative. So usually you should always look at this. And there could be even something like the deep test cluster is, let's say, having a problem with the file system, or you have some problems with the scheduler, or there are different aspects, or there's a scheduler maintenance plan to upload a new version, or the whole system is in maintenance maybe next week. So all of these information usually are often on these welcome screens, very important ones, because usually everybody sees it. Everybody's looking into this system with the SSH access to basically learn how it works. And of course, we will then have subsequent practical lectures where we then start compiling a C program in parallel using MPI. Then we want to use a scheduler, so we submit something to the scheduler with my identity, things we will learn later on in the lectures. This is really just focusing on understanding a bit practically how you use now SSH, the SSH keys, in order to access these interesting systems. And with this, I think we can go a little bit further and think about now what's happening with the Icelandic system. So far I just demonstrated something on the deep test cluster, and now I was saying, well, UNIX should be working there the same way, SSH should be working there very similar. So the UTIN system, as you see here on the website, I would encourage you to go to as part of this practical lecture. When you listen to this video, please find in the bibliography in the end always the real links. Here it's an interesting system which is in the university network. That means it's only reachable within the university network, so specially protected, which makes sense because in the one hand you have just username password, so it's not really well protected like SSH keys. On the other hand, it's just a teaching cluster, so it's really unlikely that many people will then use this cluster which are outside of our university. So it's really a smaller system that you see. There are 4 CPUs, 2 times Intel Xeon CPUs we were going to use here and there. So it's not really a very big cluster, but we can actually use it quite interestingly for lots of different tasks and to learn essentially just the basics of MPI. So the only trouble then, of course, with the login is, firstly, we don't have any more this private key, right? So we have to get somehow a password, and that is what you will receive here as part of the course. So don't worry about this. And also the username will be provided for you. So all what's left is to use then this username with UTIN, right? And this could be from the Mac and Unix users or Linux users under you, just done with this particular kind of phrase if you want. So your specific username on UTIN. However, I just want to give you this again, accounts planned basically next week, of course, but also already a head start. Think about that this is only reachable with a university network. So the workaround that works and that I will demonstrate is usually use Heckler first. Heckler is open with SSH, so you can basically go to it. And once you are there, you can make another hop to use basically then UTIN. Heckler is not really a H+C machine as such. UTIN is this. But we use it essentially to go into the university network, and from within the university network, we can then hop to the UTIN system. So let's see how that works when we use now basically, for instance, Mobixterm, right? I think I'll log out here. You have trust me now that's the same environment we have been before. You remember we were doing here some interesting things in the spring course. We had created this directory assignment 1, for instance, but this is really now again essentially going into the same work environment. So let's switch this. Let's assume I shift from Jülich to Iceland. Now I have UTIN as a cluster I have to work with. So how would that work? How would this look like? And as I said to you, I was basically in touch before with the university, of course, then as you are with us. That means I would have a username here. Now I'm very lucky, there are not many Morrises around here, so I can say I'm Morris. And this is what I got as a user account here in Iceland. But what's also interesting is that you have these system names. And as I told you, usually I would go utun.hui.hui.is, usually. But as it is, let's say, not open to the world, and I'm not in the moment in the university network, then I would have to go via Heckler, right, which is another system. Also think about that we use a specific username, but we skip here the private key. Now this is a system which operates under username and passwords. So let's use it just like this and see what happens. Right, so basically you log in into the system, and this is here because essentially this password is stored in Mobixterm. So when you use it for the first time, you're now prompted essentially and have to give in your password. But essentially, as I was using it and testing it before that it all works here, as this kind of lecture, this password was stored. So this is really needed. You have usually a prompt where you have to actually put in your password. I think I have here an example how that looks like. Again, you basically have here for the first time SSH Morris at Heckler.this, and then the key is basically here added to a list of known hosts that is not directly related to this connection. It's just helping for further connections. And here you see Morris at Heckler. Here I put in my password usually in this part of this. This is just, let's say, for further, let's say, connections. And basically here you see I normally have to provide a password. Again, in the demonstration I just showed you, I have done this before, so it's stored for a while. And now I'm actually on Heckler, right? So we said this is not our goal. We want to go to Utun. However, if I increase it here a little bit, maybe, and we know the command by now, and I think now you already learned that, you know, it's in a way always a couple of, let's say, 50 Unix commands you really need to know by heart, but the rest is really something you can look up. And here you see it's really Heckler, the system we talked about. And what we want to do, as I said earlier, is now to really establish a connection essentially to Utun. And we also learned how that is working. We can here do just SSH, because now I'm in a Unix environment. I don't need Mobixterm again, essentially now creating here a session on top. Rather, I'm already on one hop on Heckler. It's a Unix environment, so I'm in Linux Unix, and this means I can actually use then my host, my username, which is Morris, at the specific machine I'm going to go to. And of course, as we talked about this earlier, now we want to use Heckler to make a jump on Utun, and because it's within the university network, that should just work. And of course, as I told you also, this is a machine with username password. This time Mobixterm was not there to store this password. Of course, we're just on plain Unix. Plain Unix is very safe. Here I have to provide now my password to go in, and it would be equally then, of course, your password, and of course Morris will be then exchanged with your particular username you will receive from us probably already next week in order to access Utun and play around. I say play around because it's a teaching cluster, so feel free to experiment a bit. Don't do too much stupid stuff. We will come to this, let's say, in the scheduling lecture when you submit maybe too much jobs to the cluster. That's what we are monitoring, and then we will come back to you. But essentially, you cannot break here very much if you want to go and do some things. You see here also very nicely, you can use the same commands as we did before, right? The ls-al was showing all what we have in terms of files, in terms of directory in Unix. And immediately we see here are some things differently, right? So first of all, the HPC course is not anymore named Spring HPC and so on 2021. Here we have just 2021 HPC course. We see 2017 HPC course parts, a NAIC workshop parts is a HPC workshop we have organized here in 2017 and 2018. So you see the environment, so to speak, is different, but you use it with the same commands. The same is true with who am I. Now, of course, I'm Morris here, but here are now, let's say, different files. We can go maybe into the 2019 course. You also see here's nothing about the ML and the deep learning scripts. Why? Because here are no GPUs. We don't want to use this on these systems. Usually these machine learning, deep learning aspects really in particular really require GPUs. That's why we go for the deep test cluster doing it there. So, but when we go to this HPC course here, in this file directory, you immediately see the both programming paradigms you will work with. MPI, as I told you, the message passing interface for distributed memory, and OpenMP, which is used basically as a standard for programming in shared memory. And of course, you can have one folder after another. CD MPI, sorry for this. And here you see several of the aspects that really come as part of the assignments, where you have several collective MPI operations. That doesn't mean anything to you, that's clear. We will talk about this when we have the different assignments and so on. Of course, we have non-blocking, blocking operations in MPI. Also, this is not clear to you. And we can create our own file data types. We can use it with data mining algorithms here, HBDB scan algorithm, which is parallel. So all of this will be coming, but just saying that, of course, now we have a different work environment, a different HPC system with different files, with different, usage in the past. And basically, this shows you already again that despite the way that we have now a complete different cluster, right? Complete to deep learning that we do on the deep test cluster. We have here CPUs, for instance, only. And we see we use different MPI and OpenMP programs we didn't found on the other system, maybe. So you see, essentially, this is all different in terms of course, what you have here on the file system. It's a different system, a different host name, yeah, Uton, a different username, Morris instead of Riedel1, but you see I can operate it in a very same way. I can still browse here through the directories, and when we come to job scripts, you will see they are also very similar when we have MPI job scripts to really operate on HPC systems and to really let them work in parallel. This is job scripts that you need, and they are looking really very similar as well on these systems than the way how SSH worked. We have seen this was very similar. The only difference was essentially instead of just the host name and the username combined with SSH keys on the deep test cluster, we really have here just plain username password with the host name, right? So, and this comes with the host name. Really, this Uton system is basically administrated like this. And this gives you just an example that despite these differences, you still are ready to work on all the different systems. Also here, we can maybe go just for finalizing this a little bit, that I'm not fooling you here. And for those, I think, who are a little bit more in Unix, they will already being a little bit bored maybe. But of course, now I'm here, I can also make here something, a new directory. Let's say it's assignment 2, and I'm here just, making examples. Or we say we have again a test file, right? And we say this is a test file Uton with a VI, and we go into this and say hello. We can say hello. This is a test file in Uton. And of course, this is not appearing somewhere in the deep test cluster. When we log in there the next time, we still don't see that in the directory. Even the directory itself is not existing in the same name. It was basically named a little bit differently, if you remember. So in a way, that's really the key aspects I wanted to leave here on the table today. There are a couple of considerations now, which I should mention, which I usually do in HPC systems, also very early, sometimes in the course or in the middle. We would visit a system. Right, you see here my message on the bottom, maybe. And of course, you can imagine what this maybe means. We have COVID-19 times. So usually in previous years, we were going and touching metal. This is very important to really understand what a HPC system is. It's not a virtual cloud entity somewhere in some data center. It's really a system you can grab. You can see it creates lots of heat. You can hear and listen that it's actually quite loud sometimes. It could be ventilators, for instance, and all the computing very densely together, connected with lots of cables that a little bit you see here on the Icelandic system, with all the different racks and the things we will also learn in the course, how you actually name these things, which are of course very important to understand if you are in HPC. So the trouble with COVID-19 is that we really not can do this on the scale of the course. So we have to see how we do this. Maybe we break it into very small groups, but there's still a risk that we don't really want to take. So in the sense, we will hope that maybe in April, the situation in Iceland will be better, so that we maybe towards the end of the course will go and check to one of these systems. Also, what I did in some of these courses, sometimes in the cloud computing course, sometimes in the HPC courses, to actually go to Vern Global. We couldn't do this in the last time in the cloud course, for instance, because of COVID-19. But the Vern Global data center is also quite impressive. Lots of HPC systems. It's close to Keflavik, to the airport in the old US space, where you have now a new data center. If you want to Google it, I will also talk about it later in this lecture. But also there, we have been there with students and really looking at these systems. And I think it's important in a way to do so. Whenever you have the opportunity to go and travel, then you see, maybe if you have interest, and you are close to this HPC systems and they offer you a tour there, it's always interesting to go there. You find, for instance, in Barcelona, there's a very interesting one in Spain, where the Barcelona supercomputing center really put or has put their HPC systems really in a church, which is quite impressive to see. Of course, it brings lots of cooling, which is quite nice for these systems. That's also one of the reasons why the HPC machines getting more and more attractive in Iceland, in Finland. Iceland is part of a large consortium, which is part of the LUMI supercomputer. We also will experience this in lecture 1. That we basically have also, of course, access to larger systems, not, let's say, only Jotun here as a teaching cluster and Gapur, the production one. Also, LUMI is basically something we can access here as researchers. And of course, there are worldwide more of these HPC systems. But this will be then much more the topic of lecture 1 that we will then have next week, where I really provide an overview of what Euro HPC is, what these different systems are. Let's not forget Exceed in the world of USA. They have lots of HPC systems, the Department of Energy, the Department of Defense, the National Science Foundation. Also in US, lots of things are happening. And if you look on the top 500 that we will do in lecture 1, you see that essentially also China is really very well, and Japan in these systems. So we will have a more broader view and also go a little bit deeper what now HPC really means. Still, it's the first lecture really providing an overview before we then dive in lecture 2 to MPI, to the details, and then have another practical lecture really to understand more how we use an MPI on these systems. At that time, we will also have then the assignment, the first one given out, which we will probably come end of next week to be released. And then, you have a couple of weeks to work on it. All right. So with this, I think we have covered everything we should in this, let's say, practical lecture. Of course, for those who are really curious, SSH can be used in many different ways. So I would encourage you to go essentially also to the web and look a little bit up what SSH really means, what the protocol entails. It has even visualization forwarding. We basically have here, let's say, the boring command line that you have seen when I did my commands in UNIX. Of course, you can see that if you have a graphical, let's say, output on one end of the system, you can also, let's say, tunnel this with a SSH by providing a -X, and then you have X11 forwarding, which essentially means in the Unix term here also, let's say, graphical aspects can be piped through the SSH protocol. And this is also maybe something of interest for people that want to, let's say, have a visualization of HPC simulations. It's also something what we will cover next week a little bit with lecture 1. And I think now it's really time to close this lecture. We are nearly at our course hours and Here's some lecture bibliography, which is very little. Please still use them and go and check them out. Some of them might be quite interesting. As I said, also in the lecture here, if you want to already prepare yourself for the assignment, please install this Mobixterm SSH client if you are on Windows. I think when you're on Mac and on UNIX, there's no necessary need for this. You have your SSH client already installed. Also have a look on our EHPC site and maybe on the other links as well, if you have time. Of course, the book is here now interesting because there's very good visualizations, but I think the other links are quite interesting to look at. So thank you very much for being part of the lecture today, and we hear us next week.